Hi class, today we're talking about something called resonance. Resonance occurs when there are two possible structures that you can draw for a molecule. Let's talk about that. One example is ozone. So I could draw the double bond on the right side or on the left side. If you were to draw this structure, the reason we do a double bond is because each oxygen atom has 6 valence electrons, and there are 3 of them. 6 times 3 is 18. There's only 18 electrons to use, and that's not enough to immediately satisfy all 3 electrons. I've got 2, 4, 6, 8, 10, 12, 14, 16, 18 valence electrons. I had to do a double bond in order to make sure that the oxygen in the middle had 8 valence electrons. But I could have drawn the double bond here, or as in structure 2, I could have drawn it here. And either of those structures are perfectly fine. Well, the Lewis structure shows one single bond and one double bond around the central oxygen. However, experiments show that ozone actually has equal bond lengths and equal bond strengths, implying that the bonds around the central atom are actually identical. So to reconcile the experimental data and theory, we need to draw what we call resonance structures. So if you're asked to draw all of the resonance structures, that means you would draw the 2 possible ways to draw this particular molecule. We draw this as having a double bond and a single bond, but since there are equal bond lengths and strengths, they're actually not as pictured above. They don't really look like this. The bonds are more equivalent to a bond and a half, each of them, in terms of the length and strength. We use the double-edged arrow as shown here to indicate resonance. So if you're drawing resonance structures, you'll draw the 2 different structures, or maybe there are more than 2. You'll draw all the possible structures with double arrows between them. In an attempt to improve the drawing, sometimes you'll see a composite picture drawn. So instead of having resonance structures like this, you would have one structure like this, where you've got a dashed line that shows that this is a partial bond. This is a bond and a half. You notice that the structures differ only in the assignment of electron pair positions. The only thing that is different between our drawings is where are the electrons, just their position. It's never in atom positions or in the number of electrons. Resonance structures differ in the number of bond pairs between a given pair of atoms. So how does actual bond length between ozone and between oxygen atoms and ozone compare to the OO single bond and the OO double bond shown in the resonance structures? Well, the length of the actual bond is shorter than the length of a single bond and longer than the length of a double bond. It's somewhere in the middle. The actual length is shorter than a single bond, longer than a double bond. It's actually stronger than a single bond and weaker than a double bond. Let's look at another example. So you can see NO3, it has 3 different resonance structures because there are 3 different places we could draw the double bond. We had 3 bonds to choose from. So how does the actual bond differ from what's drawn? The length of the actual bond is, compared to the length of a single bond, it's actually going to be shorter than a single bond, but it will be longer than the length of a double bond. And the strength of the actual bond is going to be stronger than a single bond and weaker than a double bond. Okay, that's it for resonance. Just know that a resonance structure is when a double bond could be drawn in more than one place, or a triple bond sometimes. It just differs in where you put the double bonds, where you put the electrons.